Ridwan, what was the statement? How the resistance depends? I made a statement last day, about the dependence of resistance, how it's vary. So for the given temperature, resistance of wire is directly proportional to length and inversely proportional to the area of cross section. So before that, did we define what is resistance? Did we define what is resistance? Anyone remember what is resistance? First of all, do we understand what is resistance? What is resistance? I want to know what is resistance. I think I made a statement. We define it what is resistance in our earlier class. Jocelyn, welcome. So Jocelyn, do you remember what is resistance?
Yes, sir.
So what is resistance? Will you give me a brief introduction? What is resistance? Resistance is the measure of abstraction, produced in the flow of currents. When the current flow through a wire, we see that sometimes wires get heat. Because of what? Because of resistance. Resistance opposes the flow of current or flow of charges. So it's the measure of MEASURE, measure of abstractions. Abstractions. Okay. The measure of abstractions in flow of current. In flow of current. Right? So how this abstraction generates? Because of collision of moving electrons within its molecules or within itself. So how does resistance depend on if we have a length of wire L? If we have a length of wire L, okay, so it will depend on the length of wire and inversely proportional to the cross-sectional area. Clear?
Yes, sir.
Okay, so if you will put a measurement scale, for example, this is a wire, L length wire, okay, and we have a battery. This is a battery. And here is a measuring instruments. Here is a measuring instruments. Maybe say the galvanometer we have over here. Okay, so I'm connecting one terminal with it and another terminal with it directly. Okay, and we are just putting one knob. Okay, and this knob is being taken from this point to this point on this path. Okay, so as it will be close to here, then what will be the resistance? Resistance will be minimum because this point are just connecting to each other as we will move, just a minute, give me a second. I have to take a call. Otherwise, he will be calling me again and again. Okay. So my mistake. Sorry, my apology. This was an urgent call. So if we will change this point, the contact point from here to there, as the length will increase, the reading of the meter will also increase. Got the point?
Yes, sir.
Okay, so it is directly proportional to the length. If you want to draw it, this is resistance and this is length. So how it will be the graph? What will be the nature of graph? How it will look like? Ridwan is back. So tell me how will be the nature of this equation? R is directly proportional to L. Anyone? Any guess? Ridwan. Ridwan, you have network issue, I think.
Yes,
Are you facing network issue?
yes, sir. I'm traveling right now, sir.
Oh, that's why. So Zeba, how it will look like? Y is directly proportional to L. Unless until you won't respond, I won't move. So you have to respond. Respond, then only I'll move. Madiha, what is the nature of R is directly proportional to L? Draw the graph and show me. Jaslene, how it will look like if we are saying that R is directly proportional to L and we have to plot it, how it will look like. Unless until you won't respond, I won't proceed further because it's the thinking process. But I may give you hints. If you have read linear equation in two variable, you must have drawn the equation y is equal to mx. Okay. Remember from that class, mathematics class. This equation is same as y is proportional to x. Y is proportional to x. This one. Do you remember anything? I'm not sure. How it will look like? Madiha, Zeba, and Jaslene. Is directly, I'm not sure. I don't know what you want to say. At least write the Jaslene, write the complete sentence. Madiha, how it will look like? Ridwan, how it will look like? Respond. There is no response from you guys.
Sir, can you hear me?
Yeah, I can hear you. You may text me, okay? If you got the answer, you may text me. Madiha and Zeba, Jaslene. Your voice is breaking, Ridwan. Madiha, how it will look like? You respond, then I will proceed further. I said I told this earlier as well. about the nature of this graph while we were studying about the Ohm's law, right? Remember, we plot the Ohm's law, right? A straight line. Jaslyn, you are correct. What about Zeba and Madiha? How it will look like? We plotted the Ohm's law, na?
Sir,
Yes.
I don't know because I wasn't there the last class
We
which
plotted
we did.
yeah, no problem. We plotted V is equal to I R. There R was constant, so it was like a straight line. So here the same situation. It is like a straight line. Okay, that means the proportionality is something is directly proportional to something. One quantity is directly proportional to other, then it will be a straight line. Now, what is the another statement that it is inversely proportional to area of cross section? You know, if we have to transfer more power, then we try to make more thick wire. Okay, if you will see in geyser or fridge, we are having heavy wire whose cross section is comparable more than the cable for the electric bulb, basically for LED or fan. So when we increase the cross section area, we decrease the resistance. When we decrease the resistance, the flow of charge will be bit smoother. Got the point?
Yes, sir.
So if I will ask you to draw the second relation, R is inversely proportional to A. How would you do that? Okay, Jasmine. How to proceed this graph? How it will look like? How it will look like? Madhya, if R is reciprocal of A, what does it mean? From top to bottom. Yes, Jaslyn, you are right. The straight line decreasing from top to bottom, right? This means that if you are increasing A, the R will be decreasing, right? So see, this line we are area of cross section, this line we have R. So as we will increase the area, the resistance will be decreased. Is clear to you of to the all student? Madiha, Zeba, Jaslyn given the hints, and Ridwan is couldn't connect. Madiha, okay, thumbs up. What about Zeba?
Yes, sir.
You got the idea?
Yes, sir.
Okay. So I already discussed some materials. If you wanna note this, you may write it down, okay? Or take the screenshot. Once you are done, let me know.
Done, sir.
Okay, Zeba is done. What about Madiha? And what about Jaslyn? Jaslyn is done because her message is over here. So I'm writing. Okay, I thought you are done.
Done, sir.
Okay, so Jaslyn, Finished. Okay. So let me move. So now we have conductors and insulators. Okay, the example of conductor is copper wire, silver wire, aluminum, tungsten, nickel, iron, chromium, mercury, and magnesium. Manganese. All these are conductors. Conductors have free electrons. When it is exposed or connected to the circuit, the free electrons easily migrate from one point to another point. That's why we use conductors for the electricity or electric devices. So see, we see that silver is its resistivity is very less. Resistivity is 1.60. As we increase, the resistivity increases, right? Resistivity increases. Resistivity increases means its conductivity decreases. What is alloy? Alloys is the mixture of two or more compounds. So constantan. It may be asked in the exams. We don't have to remember the numbers, but we have to remember how the alloys are being made. So see, it is 49.86. Resistivity is more. It means conductivity is less. So this is nickel and all. And see, this is the 10 to the power 14. How much resistive are these? As this, so it's tough to flow the current when these with these rubber, glass, diamond, and dry paper. What about water? What about water? Water is good conductor or bad conductor? Water is good conductor or bad conductor?
Good conductor.
Bad. Okay. So Jasleen is saying is good conductor. What about Zeba and other one?
Good conductor.
Good conductor. So there's two type of water. One is salted water, and other is distilled water. Water. Which one is relatively the best conductor? We have salted water means the water in the rivers or on the sea. Another is the distilled water. Relatively, which one is good? Salted, of course.
Salted water.
Okay. So Madhya, did you say something?
Salted water.
Okay. So salted water. So there is some more discussion. Table reveals that the Li is generally higher than that it constitutes metals. Okay, alloy do not oxide or burn readily at high temperature. For this reason, they are commonly used in electrical gadgets or devices. Electric iron, toaster, etc. Tungsten is used almost exclusively for filaments of electric bulbs, whereas copper and aluminum generally used for electrical transmission line. Got the point? So these are the important points. Okay, tungsten. Yes, sir. So you write down these points. These points may be asked in the exam directly. Ridwan, you are missing class, okay? I think we already discussed few of these in the in the earlier class, right? I think Zeba is getting benefited from this class. So your main thing is okay. So did we solve this question? Jaslyn, did we solve this question?
Yes, sir.
Yes. Okay, so I think we did this question. What about Zeba and the another one? Zeba, Zeba or Madiha? Do you remember? Madiha, do you remember?
Yes, sir, we did it.
What about Zeba?
Yes, sir.
You did this question?
Yes, sir. I did.
You did, you were not present, you said that.
I saw the recording.
Okay. So now move with these. If you have any doubt, we can consider, otherwise we will be moving. So we did this as well. Now. Okay, just give me 1 or 2 seconds. I think there was one more question we have to think of it. Okay, just give me a second. Just give me a second. I thought I put that question, but I am not getting it right now. So it may be missing. This is based on the table. Give me 1 second, okay? Just disable back. Okay, this question is already here. I'm getting solution as well because it's asking for the to use the table. Okay, that's why I copy the all part. So the what the question is saying? Question is saying that the resistance of a meter wire of length 1 meter is 26 ohm at 20 degrees Celsius or degree C. If the diameter of wire is 3 meter, what will be resistivity of metal at that temperature? So anyone can try. Let me have a pen and hide the solution as well. Okay, this was already the question over here. So will you try this question? Just do it and show me. Length is 1 meter and diameter of the cross section means this is the diameter. Okay. Diameter is 0.3 meter. This is the D. This thickness is 0.3 millimeter. Okay. So we have to find the resistance, that is rho L over A. And we have to see how it is going to happen. We may write what is the given information again. The resistance is already given. So you may write the resistance is 26 ohm for the temperature, that is T is 20 degrees C. Then what will be the resistivity for this metal? Then we have to find rho. Question clear to everyone?
Yes, sir.
Okay, so I have solution from Jaslyn, I think. Okay, Jaslyn. I thought you are giving me the answer. It's 20. Is minus 6 ohm. Resistivity will come in ohm. Resistivity will not come in ohm. The first thing is that, Jaslyn, resistivity never comes in ohm. Okay. So if although maybe or may not be your answer is correct, but the unit of answer is not correct. So what about Zeva? Did you get any answer? And Madiha, any response from you guys? Ridwan is also back. Any
Not yet.
response? Okay. So see what we have to say. We have to find the resistivity, and resistivity is this rho. Okay, so we will write this equation in some different manner. Let me see what Jaslyn is saying. Ohms meter. Okay, maybe this is true. So first of all, we have to find the area of this cross section. Okay, so area is pi r square, and r is d by 2. Pi d by 2 square, right? So we have to find this area. This is, you may write, this is 3 mm. So how we do we have to change into the meter? Of course, we have to change into the meter. So this will be the D is 0.3 mm. So it will be 0.3 into 10 to the power 3 into 10 to the power minus 3. So either you may write 3 into 10 to the power minus 4 millimeter, sorry, meter. So it is now converted into the meter. Why we are changing into the meter? See, in SI unit, we write mass in kilogram, okay, time in seconds, and length in meter. Length in meter, right? So this was in millimeters, so we converted it into meter, 10 to the power minus 4. Clear? No issue? So if we will substitute all these, then this may be, I don't know how much they are taking. What the value of pi? You may keep that 22/7. And D is now your 3 into 10 to the power minus 4 divided by 2. Square of it, right? So this was the some transformation. So I'm keeping it as it. No problem. So we have to solve it. I think it's really area will be 22/7. And this will be 3 square will be how much? 9. And 10 raised to the power minus 4 will be minus 8. And this will be 4 again. So this much will be the area. Should we write it on? Write it down. So so how we will solve it is really going to be tough. Nah? This will be 11 and this will be 2. So this will be 1199 into 10 raised to the power minus 8 and it will be 14. So we may write it approximate. This 99 will be 100 if we approximate, and this 14 is equal to 15, and then 10 is to the power minus 8. See, I approximated it, okay? It's clear? We approximating it for the smooth calculation. We approximating it. I must have to write. We approximating it. We approximating numbers for a quick calculation. Quick calculation. Agree with me? So again, if I'll say now, it will be around 15, 6 and 90. So it will be around 7. Around 7. Again, I'm saying around 7. So 7 into 10 to the power minus 8 is the area. 8 to the meter square. So you may write it is 7 into 10 raised to the power minus 8 meter square. I'm saying we are approximating, highly approximating it. So resistance we already know. So keep the all values over here. This will be if we are taking this side, so rho r time a divided by a. This will be the expression for rho. Clear? All are sleeping. Madiha, Jasleen, Ridwan.
Yes, sir.
So did you try this way only? So first of all, we find the area and then we are trying to figure out this rho. So R we know R is given And area is now 7 into 10 raised to the power minus 8. And we are dividing it by length is 1 meter. 1 meter. Length is 1 meter, so it is like that. So just multiply 26 into 7. 26 into 7, how much it comes? 26 into 7. I'm doing it for you guys. 26 into 7. Is right? 182 into 10 raised to the power minus 8. Right? Is 10 raised to the power minus 8. So 1.82. Just I'm doing the final step. I'm sorry, I really made this screen very messy because it's like that. Then 182 into 10 raised to the power minus 8. So what I'm doing, I'm multiplying it by 100 and dividing it by 100. So if we will multiply it by 100, the point will come out to be 1.82 into 10 raised to the power minus 8 and 20. This will be minus 6. This is what we are. We get the answer. Everyone, how many of you got the solution? Honestly, Jaslyn has messaged me. Yes, sir. Yes, sir. Madiha,
Yes, sir.
anything in your mind?
Not complete.
So not complete. Ridwan, anything in your mind? Okay, Ridwan is not responding. What about Zeba? She went. So where is your confusion, Madiha? At what point you are stuck? At which point doing so is Ridwan? Okay. Madiha, at which point you have confusion or you are stuck?
Sir, there where you got the answer 3 into 10.
3 into 10. 3 into 10, where I got 3 into 10? See, if I get chance, I will pick the another pen, and it's really challenging. Now I picked up another pen. See, I will mark over here. This line is okay to you?
Yes, sir.
Okay, so R is given, L is given, and diameter is given to find the area because this is circular area. Okay, so we will be using area of circle pi r square to find this. We don't know only this quantity rho. We don't know the rho. So we took the rho outside. So this R will be multiplied with A and this L will come down. So in numerator we will be leaving with R into A. In denominator we will be L. We already given it is already given 26 ohm. So that's good. The length is already given 1 meter. So it's good. What is we have to calculate? We have to calculate the area. Clear till this point?
Yes, sir.
Okay. So how we will find the area of a circle? How you will
Pi,
find the area of circle?
pi r square.
Pi r square. Okay. So what is relation between radius and diameter? The radius is half of the diameter. Okay. So we have written pi d square by 2. Is clear?
Yes, sir.
So pi we have put 22.7 and we have just calculated the diameter, because diameter is given in millimeter. So we have in SI unit, we have to calculate every quantities either in kilogram, in second, or in meter. Okay. Another dimension is not accepted. So it was in millimeter. So we solve it like 3 into 10 to the power minus 4 meter. So see, millimeter, millimeter, centimeter, decimeter, meter. So 1 centimeter is 100 centimeter is visible,
Yes, sir.
is 1 meter. Okay. Similarly, 1000 millimeter, the 1000 millimeter is 1 meter. My my apology. This is not right ink. This is not right ink. It will. So this 1000 millimeter will turn out to be 1 meter. So when you will change this point as well, it will take 10 to the power minus 4 meter, right?
Yes, sir.
This was your confusion.
Yes, sir.
So it's clear now.
Yes, sir.
Okay. So now we got this value as well. We are substituting over it here. So as we will substitute from here, we have jump over here. Okay. So this is 22 over 7. 3 square is 9. 10 to the power minus 4 square is 8. 10 to the minus 8. And this 2 square is 4. So what the our problem? We just solved 22 or 4. This is half 11. This is 2. So 11 9 are 99 and 7 2 is a 14. So now what we are left with, this is the number really bit hard to calculate. So I substituted is approximated it as 100 and 14 is approximated with 15. So if we will divide 100 by 15, it will be 15 sevens are 105, right? So again, I approximated it with 7. So it is somehow approximated 7 into 10 to the power 8. Jaslyn, are you getting? Zeva is back? No, Zeva didn't come. She is left. So we somehow reach 7 into 10 to the power minus 8. So we substituted over here 7 into 10 to the power minus 8. Now our task is to multiply 26 by 7. Okay. So we multiplied it. We got 182. Now this 182 into 10 to the power minus 8. So in the scientific notation, we have to write like this. Okay. Okay. So 182 instead of we would like to write it 1 point something. So for that, I multiplied it by 100 and divided it by 100. When we will divide it by 100, it will become 1.82. So we taken this division in here, but we are left with this 100. So then when we have 10 to the power minus 8 into 100, it will turn out to be 10 to the power minus 6. Good. Is clear?
Yes, sir.
Okay. Jaslyn, is clear to you as well? With one at least, did you get something? What does the red tick, what does the green ticks means? Jaslyn is from your side, green tick. What does it mean? I'm not that much to technology. Will you tell me, Jaslyn, what is this green tick? Ridwan is clear to you as well? Madhya got, I think, almost all the steps. So write it down and try to solve it on yourself. That's good. From now, I will keep much spaces on the screen. It's tough to understand. Madhya, did you note it?
Yes, done.
Okay, what about Jacqueline? You noted it? So try to make the orders, okay? Because before the numerical, I don't know how much space it will consume. So accordingly, I used to put the questions. But when we come to solve it, we have to see each and every steps. So it takes little bit more space. That's why it's done, sir. Okay, so the next question on the screen waiting for you. I hope so. It's visible. Nadia, the next question.
No, sir, it's not visible.
Not visible. So now it's visible. See. A wire of given material having length L and area of cross section A has resistance 4 ohm. What would be the resistance of another wire of same length having length L by 2 and area of cross section 2A? Do it. You have 9 minutes. First of all, try to draw a diagram according to the question's information. Jaslyn, did you get idea how to proceed? Madhya, are you from Delhi?
No, sir, Lucknow.
Okay, okay. Lucknow. So are your family in Delhi? Grandfather or someone?
No, sir.
Okay. There is one guy, one of my friend, his name is Ansar Kidwai. He's from Delhi. He lives in Lucknow. He has businesses. So I thought maybe.
Oh,
So did you got the idea how to proceed the question?
yes, sir.
Okay, then do it and show me. Any progress? Jocelyn, any progress? The first situation is not done. So first situation is a wire of length L and area of cross section A has some resistance. So in the first case, R is rho L over A. This is given that it has 4 ohm. Then 4 ohm is equal to rho L over A. The first situation. Another situation is that what would be the resistance R when rho is the fixed and the length L over 2 and the area is 2A. So see, this is rho L over A and this 1 by 2 will be 1 by 4. See, the 1 by 4 is as it, and this is rho L over A. So 1 by 4, you just keep it and say this is nothing but R. In this case, R is how much given? The value of this in first case is given as 4. So just put 1 over 4 into 1 over 4. Sorry, 4. So it will just give you 1, right? Everyone got the solution?
Yes, sir.
Okay, so how much it will be the unit of this? 1 ohm, but it could be solved by you guys, okay? You couldn't solve it, or I couldn't wait for your solution. Both is good. So Jaslyn, is good to you? You understand the process? Yes. So see, this is the situation where we have to compare the two situations. Okay. In one situation, the question is given that for this information, we have this information. Okay. But he said that in the next part, if we do L by 2 and 2A, then how will be the resistance changing? So we have to connect it from the situation given earlier. So I did nothing. I just solved the second part, kept the first part as it, and then I just replaced the value of rho L by 8 is equal to 4. Here it was 1 by 4. So just cancel the situation and then we got R2 as 2 ohm, right? Clear? So I will be sending you more numericals based on this as a home assignment. And next time we will be studying the resistance of system of resistors like series and parallel combination. Okay.
Okay, sir.
Okay. Any confusion, any questions regarding today's class?
No, sir.
You understand each and every concept?
Yes.
Okay. So Madhya is in hurry. So we'll meet